Okay, so let's start our lecture today. So, yeah, I have the written result from last time. Okay, so, uh, let me think. So, okay, so now, so if I recall, so let's so this is real axis. This is like the imaginary axis. And then we split the region into like 8 parts, right? And then, yeah. So last time I'm doing the analysis on this second part. Okay. So 3, 4, 5, 6, 7, 8. Okay. So and then so. So we have the condition that so we assume so this is omega 1 tilde and then this is omega 2 tilde. Okay. So assume that this modulus of this omega 1 tilde is equal to k modulus of omega 2 tilde plus x. Okay. So now we are in the case where, okay, so in this 2, okay, so we have that for n equal to 1 and n bigger than k. So we have that 1 over this minus omega tilde omega 1 tilde plus n sorry, I think this is n bigger than k. Okay, so n omega 2 tilde, okay. Square. Okay, so which is equal to negative 4n a1 a2 minus 2i n square a2 square minus a1 square. And then over 4 times n square a2 square plus a1 square. Okay, so and then we compute the sum on this one. So then so we are interested in like so the sum. Okay, the sum is given by okay. So we take the summation n star k plus 1, right, to infinity. Yes, so you are going this direction. So okay. Okay, so let's just put it here. Okay, so let's just put it here. This is negative 4 and yeah, so same thing. Okay, so let's do like yeah, so I think we wonder like what happened in this 8, right? So can we do like the same sum in 8? Okay, so so in 8 the sum they are like they are like finite, right? So if you fix like n values, then if you're summing over n, the sums are exactly finite valued. Okay, and again, so these points. Okay, so let's so do I sum as okay, so let's do this sum. So okay, let me think. Yeah, so I think I forgot one case. So there is a case where m equal to 0, right? So when m equal to 0, so this is just the sum of this omega 2, right? Okay. Then we get so when m equal to 0, so just the n square omega 2 square, right? Okay. Oh, by the way, so I also have the omega 2 tutor square. So I also have the omega 1 tutor is equal to a1 minus I a1, and omega 2 tutor is equal to a2 plus I a2. Okay. So these are my initial values here. So yeah. So do I compute this one? So okay, so let's do some computation here. Okay. So let's say as for one term, 1/n squared. Okay, so this omega 2 is this guy. So when you expand it, it's just like a2 squared plus, it's like just the 2i, right? A2 squared, right? Okay, so okay, so what is, okay, so 1/2i. So 1/2i is just negative I, right? Because you multiply by, sorry, 1/i, yeah, so yeah, so okay. Yeah, so okay, so let me think. Oh, this one converges actually. Yeah, so this one actually converges. Okay. So you pull out these constant terms. Okay. You pull out these constant terms. Okay. Okay, so this one converges. Okay, what about okay, so what about this guy? Uh, okay, so this guy, let's just leave it here. Okay. So let's say in 8. Okay. So in 8, okay, so let's just ignore the m equal to 0 case. Okay. So just leave it for a while. Okay. So because I think the m equal to 0 is like the same thing, right? You will get something similar to this guy. So what is that guy? I think you will get. Let me just write it down. Okay. 1 over n squared omega 1 squared. Okay. And then okay. Because you're just adding. Oh, okay. So okay. Okay. So so 1 over n squared 1 squared 1 over n squared. Sorry, omega 1 tilde squared. Yeah, 1 over n squared omega tilde 1 squared equal to 1 over n squared. So omega 1 tilde is exactly a1. So a1 squared. Okay. This is negative a1 squared. Okay. So minus 2i. Okay. a1 squared. Okay. Okay. So then is I over 2 n squared a1 squared. Okay. I then you get 1 then cancel. Okay. Okay. Let's see. So I over 2a1 squared. So take the sum. 1 over n squared. Okay. Let's see. So yeah, so we're done in this case. So what happened for? Okay, so yeah, m equal to 1. Oh, sorry. Yeah, maybe I should use n equal to 1. Okay. Oh shoot. Okay. I'm already using it, so it should be n equal to 0. Okay. So it should be n equal to 0. Okay. And Okay, so I'm already using this factor here. Okay, so this n equal to 0, and then I'm summing over this n here. Okay, but yeah. So in this case, yeah. So, but yeah, I want to make this respect the letter here. Okay. So okay. So let's see. So n equal to 1. Okay, so when n equal to 1, I have that, what do I have? Oh, okay. Yeah, I'm having the triangle here. I think for n equal to 1, there's no problem because this m, when n equal to 1, right? So we have that this the first starting one, right? So the first starting one are already like it's already bigger than this. Yeah, so we have that the modulus of m omega 1 tilde. So m times that, okay, whatever, is bigger than, strictly bigger than, okay. Yeah, so we are assuming that this modulus of omega 1 is bigger than this modulus of omega 2 too. Okay. So this is our assumption. Okay. So this guy is bigger than this modulus of omega 2 for our m bigger than equal to 1. So therefore, yeah, so therefore what we get is that we're just getting, with the sum is just m equal to 1 to infinity. Okay, so however now, our denominator is not just this guy, I think. So it will be m omega 1 tilde plus n equal to 1, so just omega tilde 2 squared. Okay. Okay, so now, what does this guy equal to? Okay, so let's do some calculation here. So, 1 over this m omega 1 tilde plus omega 2 tilde square, which is equal to, okay, so m times omega 1, which is m times a1 minus im times a1 plus, okay, m times that, okay. And then what is omega 2? So omega 2 is a2 plus ia2, okay. So, yeah. So after I collect all the terms, I collecting all the real terms. So the real terms are exactly ma1 plus a2, right? So these are like the real terms. And then plus, and then for the imaginary terms, I'm having this negative ma1 plus a2, right? Okay, so okay, so now I'm taking the square inside, right? So while I'm taking the square, so what do I get? So I am squaring this term. So first I square this term, which is m square a1 square plus 2m a1 a2 plus a2 squared m a1 a2. Okay. Okay. m a1 times a2. Okay. And then so minus also plus 2i times the product, right? M a1 plus a2 times negative m a1 plus a2. Okay, let me see whether this is recorded or no. Okay, almost recorded. Okay, good. So, and then, okay, so, yeah, sorry, I'm running out of space. So here, there's another term. It should be minus, right? So minus this one squared. So what is this one squared? Okay. M squared a1 squared minus 2m a1 a2 plus a2 squared. Okay. All right. So what does this cancel to? So so namely I have this term and this term cancel out. This term and this term being cancelled out. And also I have, so I'm leaving with this term, right? 1/4 and a1 a2. Okay. So plus, so this is imaginary term. So again, I will like expand these imaginary terms. Oh, so this is again a perfect square. So here, let's just write it in terms of a2 squared minus m squared a1 squared. Okay. Okay, so this is equal to what? So now let's make a conjugate. So let me see if I can finish this. So so 4m minus 2i. So this is already done. Okay. a2 squared minus m squared a1 squared. Okay. So same thing. Okay, so now let's see what happened on the denominator. So on the denominator, I'm having. So okay, so let's talk about the let's just focus on the denominator. Okay. So yeah, so for the denominator, so this is equal to so I get, okay, so 16 m squared a1 squared a2 squared, and then so this is plus, right? 4 times, okay, so this guy squared, right? Wait, let me see. So this is 22, okay, yeah. So this one square, this is equal to let's do a square here, okay. So a2 to the 4th power minus 2 a2 squared times m squared a1 squared plus m to the 4th power a1 to the 4th power. Okay, so now, so this 16 actually cancel out with 8, right? Yeah, and then becomes a plus. So yeah, so this just becomes